All right, here we go. It's been a while since I've done one of these, and I wanted to chat through some math, and I've been doing a lot of it. So I'm here to walk you through some of it, and I think we've got a lot to talk about, but I will try to make this snappy and quick. So, what do I want to talk to you about today? I want to talk about BTC Risk, and I want to talk about BTC Credit, and these are two formulas that Strategy has come up with, and they have put this on their website. As you can see here, BTC Risk and BTC Credit. I guess before I go any further, I need to say none of this is financial advice. This is not a sale of security. This is for informational and educational purposes only, and intending to provide a mathematical framework of how to think about risk and credit and these different instruments. So thank you for being here. It looks like I got some people in the chat, so this will be fun. Okay, so what is BTC Risk? So BTC Risk is the probability that the BTC rating falls below 1 at the end of the duration period. So there's a few things here. BTC rating. BTC rating is the amount of notional outstanding relative to the Bitcoin held on the balance sheet. And so if the BTC rating falls below 1 at the end of the duration period, that is the BTC rating would be the Bitcoin value falls below the notional outstanding of any of one of these individual instruments on a cumulative basis. Now, at the end of the duration period, what is duration? So how duration is calculated on this website is the Macaulay duration for the preferred equity. The Macaulay duration is a function of, it's effectively the 1 divided by the interest rate. And that gives you basically how many years do you have to hold that instrument in order to technically get paid back from the dividends over that horizon, basically to earn out the yield. So that's the duration is an interesting framework that typical bond or credit holders will think about, like how long do I have to hold this instrument in order to get paid that yield. So it's helpful when thinking about the risk side of the equation. Now, the other thing I want to talk about here is the credit. So the credit, which I think is the most interesting and most fascinating piece here, this is the credit spread necessary to offset the BTC risk for a given security on an annualized basis. So as you can see here with BTC risk, it's the probability that the BTC rating falls below 1 at the end of the duration period. So this is like a long-term measurement of risk. So if you look at the perpetual preferred equities, this is effectively saying, based on the assumptions here at the top, a BTC price today of around 69,000, volatility of 45%, an annual rate of return of 30, over the horizon of 8 years, for example, let's just do STRF. Over the horizon of 9.9 years, there's a 0.27% chance that the notional value of the Bitcoin on the balance sheet, or the value of the Bitcoin on the balance sheet, falls below the cumulative notional outstanding for STRF. So that it's just to show like a risk over a certain horizon. And now what the credit spread does is puts this into an annualized basis, so you can get a perspective of like, how can I compare this to like a bond or a credit default swap? And that gives you a view of BTC credit. Now, one thing that's been fascinating is just watching people try to digest and think about STRC relative to SATA, and trying to digest the comparison between the two. And there hasn't been a great way to do that yet, but I wanted to take the SATA instrument and put it next to the STRC instrument and take this framework from Strategy's website, put them next to each other so we can start to think about a mathematical framework of the comparison between the two instruments, because it's difficult. It's difficult to compare because there's so many different things, right? So I'm going to take through this experience here, I'm going to take a quantitative view of this BTC risk and BTC credit. Obviously, there's a qualitative view as well. There are other qualitative things you got to take into consideration. Um, Strategy's got a significant amount of convertible bonds held on the balance sheet that's senior to all the pref instruments. Um, there's different types of risk associated with that. Cash flow risk. You've got uh, track record, how long you've been operating in the capital markets, et cetera. So there's a whole qualitative side to this as well. But I wanted to show a mathematical framework because I think it's a helpful landscape. So, what do we need to know? We need to know the STRC BTC rating. We need to know the STRC BTC risk, STRC BTC credit. And we also need to know, if you go to the Strive website, there's BTC Treasury Analytics here. And once you see the BTC Treasury Analytics, you could come in here. We're making some revamped edits to this, but you could see the BTC rating here, 2.13x. And what I have done is built a vibe coded visualization of the relativities between STRC and SATA. So let's make this bigger because the screen is a little bit small. And we can start to compare here. Okay, so putting the BTC ratings next to each other. Okay, STRC has got a BTC rating of 4.3 and SATA has a BTC rating of 2.1. Now, on the onset, you look at those and you say, whoa, those are like significantly different. But for example, SATA is 51% lower than STRC on a BTC rating basis. But again, you got to think about, well, the composition of the balance sheet is different. So, right, Strategy's got convertible debt on the balance sheet. So BTC ratings aren't necessarily one to one. They're not comparable. They're probably not the best view of just general risk for these particular instruments, because the credit is the dividend payment, right? Like, do I feel confident that I'm going to have capital to get the dividend payment over the horizon? So we need to take into consideration tons of other variables. So let's look at them. STRC price as of close of day, 99.97. SATA, 99.00. Stated yield, 11.5 versus 12.75. The effective yield between the two, 11.5% and 12.8%. So the difference in effective yield is 137 basis points. And the big question is, what should it be? And I think that's fascinating. And we'll begin to think about this over time and start to understand a mathematical framework. So we're going to get into it. The durations, they're very similar. STRC about 8.7 years, SATA 7.7 years. Now, BTC risk, again, on the strategy website, you're thinking about the risk over the horizon. So over that duration period, 0.8% to 0.8% chance, the Bitcoin on the balance sheet falls below the notional outstanding based on the underlying assumptions, 30% BTC ARR and 45% volatility. And then the BTC credit here, the relative is 9.4 relative to 44. So, okay, why are we doing this? We're doing this because we are underwriting a long-term view of Bitcoin, and we are taking a long-term perspective of Bitcoin, a long-term annual rate of return, a long-term volatility measure. And based on those views, you can start to compare the credit spreads between the two. So what I've done here, and we'll try to make this so you can see the whole thing. I wanted to map this out onto a graph, and I wanted to look at what is the mathematical credit spread between the two mathematically based on the underlying assumptions, and then compare that to what the market is showing based on the delta in the effective yields right now. So the modeled STRC credit spread is 9 points, 9.4 points right now today. So you can see that here. The blue line is STRC, the red line is SATA. So the x-axis is BTC rating, the y-axis is basis points of credit spread. And you see here, STRC is down at 9.4. Now, mathematically, based on this framework, SATA credit spread is up here at 44.8. Okay, so you look at the difference between the two, and you can see as as you go lower in BTC rating, the credit spread goes higher, but it's not a linear relationship, right? It's it changes over time. It's like, I guess, an exponential relationship, and I guess the inverse exponential relationship. But I think one of the most fascinating things here is the difference between the credit spread between the two, mathematically, based on this framework, is 35 basis points. Now, what the market is showing is that the credit spread between the two is 137 basis points. So there's a delta. What the market is saying right now is there's a delta between 102, a delta of 102 basis points between the mathematical model that Strategy has on their website and what the market is showing. Now, why is that? Good question. And we're all trying to figure it out at the same time. But you can see, and you'll see this very dynamically here, as you change the underlying assumptions of BTC ARR, you can see how the curve of credit changes over the different assumptions. So let's go back to the base assumption, 30% ARR, 45% BTC vol. Now, you could also change the BTC vol, and you could see how that also changes the credit assumption. So let's go back to the base assumptions here, click reset. So there's a few things that you could kind of glean from this. One, you start to back into what is the market, what does the market think that the long-term average BTC ARR and BTC volatility is, and we could try to start to back into some of those numbers. So effectively trying to bring the spread to zero based on our underlying assumptions here. So interestingly enough, if you change the BTC ARR, so if you assume Bitcoin compounds annually at 21% here into the future, or over the next 7 years, and has a vol of 50%, then this credit spread mathematically makes sense. The credit spread that the market is giving mathematically makes sense. You can see that over here in this table on the right. So that would show the model for STRC being 81 basis points of credit spread, and for SATA being 220 basis points of credit spread. You see the model to market is about zero. So I think that's fascinating, right? One of the questions becomes like, what is your? I think if anybody's underwriting this, it comes down to what is your long-term annual rate of return perspective on Bitcoin? What is your long-term annual BTC vol perspective over the long term? And I put this number here for comparison. A BTC ARR of 21% results in an implied Bitcoin price of 250,000 by the year 2032, which would be a $5.2 trillion market cap. But to put that in perspective, I think gold right now is a 30 plus trillion dollar market cap, just to put it in relative perspective. So let's go back. The base assumption that we have in here is 30 BTC RRR and 45 BTC vol, which is the same base assumptions that are on the Strategy website from here. That would result by 2032, the estimated Bitcoin price with a 30% ARR over that horizon would be 407,000, right? And you've got, and I think that's the decision-making process here when trying to underwrite these particular variables, to look at these multiple different things here. So, but again, just wanted to point out a lot of people are looking at SATA and stretch relative to each other, which is interesting, but I think they have to, I think it's helpful to think about the relative risk profile compared to everything else, and the relative risk profile, like how far of a tail scenario is it? And if you're comparing like a very small tail scenario to a very small tail scenario, the actual credit spread, which we're kind of pointing out here, mathematically is pretty small. Again, all this is based on the underlying assumptions, and none of this is financial advice. Okay, Now, where this gets super interesting is like backtesting it. Let's look over. Let's look at the volatility surface. Let's look at volatilities, different volatilities, different Bitcoin annual rate of returns, and see the what is the market imply, what has happened over history, and what can we glean from this. So, what this is showing, this is a three-dimensional model showing BTC ARR on this x axis here, um, BTC volatility on this x axis over here. You can see BTC vol. And then the vertical y axis, this is spread. So, this is the credit spread. Basically, we're taking, I wanted to visualize at different rate of returns and different volatilities, what does the surface of credit spread look like? And that's what we've got here. Now, this orange line, this is the yield implied locus. So based on what the market credit spread is right now for between STRC and SATA, which is what do we say? It's 102 points based on these ARR assumptions. That orange line is representative of where the market is effectively saying the credit spread is between STRC and SATA, which is fascinating. And then the pink line is what the modeled credit spread is based on these underlying assumptions. So again, the underlying assumptions be 30% BTC ARR, 45% BTC vol. So let's look at how these things change when you dynamically move these, right? So if you drop the volatility, you can see how the credit spread really diminishes very low into this surface, right? It gets effectively very flat, which makes sense if you're thinking BTC being very high performing, but the volatility being very low, then the relative risk profile kind of drops into this much flatter surface. Now, conversely, you go the other direction, you can see how the modeled risk profile goes further up onto the credit spread frontier. Okay. And same thing here. You can see how it moves and changes with the BTC ARR assumptions. Okay. Now, there's some dots on here. So I wanted to put into perspective, like what has happened in history. So maybe let's hide these for a moment. Reset. And these dots are all different points in time over history. So let's look at. So what I've got clicked on the screen right now, this is the 6-year, 7-year, 8-year, and 12-year horizon BTC ARR and BTC volatilities. So the 8-year being the purple dot, the 6-year being yellow, 7-year pink, and 12-year orange. Okay, so you can see some of the longer term horizons. Obviously, the ARRs are very high historically, which makes sense. There was, very high performance in Bitcoin's history earlier in the 20 teens, but the volatility was also very high. So you could see it up on this axis, right? Like volatility high and return also high, pretty high up here. Okay, now the one thing that's fascinating is if you include here the assumed chart spread. So this is the assumed credit spread based on these assumptions, 30 and 45%. They're effectively in line on the efficient frontier of those historical time horizons. You plug in some shorter time horizons and it's a little bit more scattered, right? You've got let's start. You've got the 5-year horizon, which is probably one of the worst time horizons you can look at right now, which is taking effectively the compound annual rate of return near Bitcoin peak in 2021 versus where it's at today relative to the volatility, right? It's been incredibly volatile over that time horizon. Now 4-year, a little bit different, and the 3-year pops out over here back on this kind of efficient frontier. So it's interesting to see that scatter plot relativity of risk between the modeled, what the market implies, and the actuals, like what's actually happened over time. So yeah, I think this is a helpful perspective to try to understand what the credit spread should be, because I think all of this is very misunderstood. There's qualitative components and then there's quantitative components. And I think they both need to be weighed and considered when thinking about these instruments. But this is a decent mathematical framework, at least to give a relative baseline of how to think about some of these things. Ideally, we will post this on the new T North website, and we get back into some of these things. And just for perspective, this is Michael Saylor's Bitcoin 2020 Bitcoin 24 calculator, which is the open source model that they created, where you could look at the current Bitcoin price and Saylor's projections of Bitcoin price over time, which is a diminishing ARR into the future. But based on this assumption, Saylor from here to 2032 has a bear scenario of Bitcoin being at $365,000. What does that look like relative to our model? That's around a 28% BTC ARR from here. And if we assume a historical volatility of 50, so if we want to get more conservative on our estimates, if we assume a 28% BTC ARR and a BTC vol of 50, the relative delta in credit spread, it would be 61 basis points between what the math is showing and what the market is providing within the current pricing framework. So anyway, I think that's it for right now. I will probably share more on this, but yeah, hopefully these puppies get to par, and we'll keep on grinding through. Thanks for the time, everybody. We'll see you next time. See ya.